Alright, let's discuss nitrate reduction. Now, nitrate, as I talked to you about, was one of those final electron acceptors. Now remember, in a reduction reaction from chemistry, in a reduction reaction, an atom or molecule gains electrons. So in this case, when nitrate is the final electron acceptor, it is reduced. Now, in order to keep this process moving at a rate that is sufficient, bacteria use the enzyme nitrate reductase in order to reduce nitrate. We can see that reaction right here. Nitrate gains 2 electrons to form nitrite. And it's the enzyme nitrate reductase that allows that reaction to occur. Now, some organisms can take this further. Some organisms can further reduce nitrite. So here in the first reaction, here's our enzyme nitrate reductase. 2 electrons are transferred to nitrate in order to form nitrite. Some organisms can take nitrite and further reduce it all the way to molecular nitrogen, N2. And it's this process from here to here that we call denitrification. Now, not all organisms can carry this out. Not all organisms have nitrate reductase. Not all organisms have the enzymes to denitrify. So now what we're going to do is we're going to differentiate organisms based on their ability to reduce nitrate. Now, this is actually going to be a 2-step process, so I really want you to focus on what is happening at each individual step. The first thing we want to determine is if an organism produces that nitrate reductase. Now, if an organism produces nitrate reductase, what should happen in our nitrate broth is the nitrate that was present should be reduced to nitrite. Now, we can test for the presence of nitrite by adding we're going to call them nitrate reagents A and B. Nitrate reagents A and B are used to detect the presence of this molecule right here. If nitrite is present after you add reagents A and B, that tube will turn a nice red color. So let's follow it here. Here's our nitrate tube. Our organism has had 24 hours to grow. We add reagents A and B to the tube, and as we can see, the tube has turned a nice red color. That red color is an indication that this organism produced nitrate reductase. And that red color is an indication to me that the nitrate that was present in the tube was converted to nitrite using this enzyme. Alright, that's fairly easy. So you add reagents A and B, it turns red, that means nitrite is present. And if nitrite is present, that means the organism produced nitrate reductase. Now, we have a problem, okay? What if the tube remains colorless? What if it doesn't turn red once you added reagents A and B? That's not necessarily an easy interpretation. All right, there are 2 possibilities for that color, or 2 interpretations, if you will. The first interpretation is the easiest. If your tube does not turn red, that means your organism did not produce nitrate reductase. Remember, when we add reagents A and B, we're testing for the presence of nitrite. Well, if your tube is colorless, that would mean that the nitrate is still around. The nitrate has not been reduced. Okay, so that's one possibility. However, we have to remember that we have this process called denitrification. So what if our organism is a denitrifier? What if it took that nitrite and it further reduced it ultimately to molecular nitrogen? When I add reagents A and B, there is not going to be any nitrite present because that nitrite has been further reduced to N2. So if N2 is present in my tube, the tube will also be colorless. So this is sort of where we reach the fork in the road. We add reagents A and B, and that tube remains colorless. It means one of two things. Either we're stuck right at the beginning of the process, or we've reduced it all the way to the end here to molecular nitrogen. So how are we going to differentiate between these two possibilities? Well, what we're going to do is we're going to add 2 more reagents to that tube. So here's what I want you to remember. All right? We have our tube. We've added reagents A and B first. And that tube remained colorless. What we're then going to do to the same tube is we're going to add zinc and we're going to add hydrochloric acid. Now the reason we do that is because the zinc provides the electrons for the reduction reaction. So zinc provides the electrons for the conversion of nitrate to nitrite, and HCl provides the reducing power. So if your organism does not produce nitrate reductase, what's going to happen is the addition of zinc and HCl will take the nitrate that is present and it'll reduce it to nitrite. So again, let me repeat. The function of zinc and HCl is to take the nitrate and further reduce the nitrate to nitrite. So the zinc and HCl is going to work right here. So the zinc and HCl are going to allow us to see, really, if possibility number 1 exists. So if that nitrate is sitting there and cannot be converted by the organism, the zinc and the HCl will do it for us. So now, let's look at the 2 possibilities here. Let's look at the first possibility. If it turns red after the addition of zinc and HCl, that means the organism does not have nitrate reductase. So what that means for us is we were stuck here right at the beginning. And what we did is we added zinc and HCl, and the zinc and HCl produce nitrite, and when nitrite is present, we have a nice red color. So that red color after reagents A and B and also after zinc and HCl is an indication to me that the organism does not have or does not produce nitrate reductase. And it's the zinc and HCl that's doing the reduction step. It's the zinc and HCl that's taking the nitrate and converting it to nitrite. But now imagine this. Imagine the second scenario. You add zinc and HCl, and it remains colorless. That colorless means to me there is no nitrite present. So even though you've added zinc and HCl, there's still no nitrite produced. What that means to me is that the nitrate was already converted to nitrite, and then that organism already reduced nitrite to N2. You cannot further reduce molecular nitrogen. It is at the end point. So even though you've added zinc and HCl, we're already well past nitrite. We're already here. And therefore, that tube will remain colorless. All right, does that make some sense? Let me go through it just one more time. All right? We add zinc and HCl. Remember, zinc and HCl work on this step right here. If nitrate is present in your tube and you add zinc and HCl, that nitrate is going to get converted to nitrite. And when nitrite is produced, the tube will turn red. So after the addition of zinc and HCl, the tube that turns red indicates the organism does not have that enzyme nitrate reductase. And it's the zinc and HCl that are reducing the nitrate present. Now let's go to the other side. What if you add zinc and HCl and it still remains colorless? What that means to me is that nitrate was already exhausted in the tube. That means to me nitrite was also already exhausted because the organism further reduced that nitrite to molecular nitrogen. Therefore, I can add all the zinc and HCl I want. There's no nitrate to reduce because nitrate was already reduced. So if it's colorless, that means to me that the organism did have nitrate reductase to start with, but it then took that nitrite and further reduced that nitrite to other nitrogen end products. Now, I think this works well. I think looking at the reaction scheme on the left here and looking at the color of the tubes on the right works well for us. Okay, in the first step, what are we going to do? All right, so we inoculated our tube, we incubated so the organism grew. The first thing we're going to do is we're going to add reagents A and B. Now, let's focus on each result. If you add reagents A and B and the tube turns red, that means nitrite is present in your tube, and that means then that this organism produced nitrate reductase. All right? Now, what if you end up with this result? What if it did not turn red after reagents A and B? What are the two things that can mean? All right, let's look here on the left. If it does not turn red, that means either we are stuck as a bacteria, we are stuck here in the nitrate form because we don't have nitrate reductase. So therefore, we're stuck right at the beginning. The other possibility, that's possibility number one. The other possibility is we took the nitrite that was produced using nitrate reductase and we further denitrified it to molecular nitrogen. Remember, reagents A and B detect the presence of nitrite. Well, you're not going to see nitrite in a tube that's already converted it to molecular nitrogen. So that is possibility number two. So how do we figure out if we're stuck here or if we're finished over here? You then add your zinc and HCl. So in this step, we've added zinc and HCl. Now, let's look at the two possibilities. If your tube turns red, that means the organism does not reduce nitrate. What that means is the organism does not produce nitrate reductase. And what that means for us is we were stuck right at the beginning, and the zinc and HCl reduced the nitrate to nitrite, and when nitrite was produced, the tube turned red. So after the zinc and HCl, a red color means we were stuck right here. Now let's look at the second possibility. Let's say we added zinc and HCl, and let's say the tube did not turn red. What that means is the organism reduced nitrate in the first step. It produced nitrate reductase in the beginning, but it then took the nitrite and further reduced it to molecular nitrogen. So therefore, you can add all the reagents A and B you want, but you'll never see nitrite because nitrite has already been further reduced to another nitrogen form. Remember, that's called denitrification. So, to summarize, if you add A and B and a red color is produced, that means that your organism reduced nitrate to right here. If it's colorless, that means either possibility number 1, we're stuck at the beginning, or possibility number 2, we've already taken it to the end. So by adding zinc and HCl, either you're going to determine it does not contain nitrate reductase, therefore the zinc and HCl produce the nitrite, that's what the red color here means, or if it's colorless after zinc and HCl, what that means is you had nitrate reductase, but then you took that nitrate and you further converted it. Alright, let's start the self-test here. So what is the interpretation for the organism on the right after the addition of nitrate reagents A and B? Now remember, when you're answering these questions, it's going to be very important you realize what's been added to the tube. That's right. The interpretation of this tube, because it's a red color, that indicates to me that the organism produces the enzyme nitrate reductase, that within the tube that nitrate was reduced to nitrite, and when nitrite is present, that tube turns a nice red color. Right? That's a very easy interpretation. Now let's look at the second tube. Again, what have we added? We've added reagents A and B. What is the interpretation for the organism on the right? You see, this is the trick question, if you will. There are two possibilities here. All right? Here's the first possibility. If it did not turn red, clearly that means there is no nitrite available. Now, no nitrite means one of two things. Either your organism could not reduce nitrate to nitrite because it did not produce the nitrate reductase. That's certainly one interpretation, and it's certainly plausible. However, here's the second interpretation. Your organism had nitrate reductase, converted nitrate to nitrite, and then took that nitrite and converted it in a series of steps to molecular nitrogen, and that process is called denitrification. So you can look for nitrate all day, but nitrite is not available because we've already further reduced it to molecular nitrogen. So again, after reagents A and B, a colorless tube means either you're stuck at the beginning, you're stuck right here, or you are stuck there at the end. So in order then to differentiate, we're then going to add zinc and HCl. So what is the interpretation of the organism on the right? You've added reagents A and B, zinc and HCl. Well, that red color is an indication to me that nitrite is now present. And if nitrite is now present, what must have occurred is we were stuck here at nitrite. Nitrate was sitting in the tube. You added zinc and HCl, and the zinc and HCl converted nitrate to nitrite. And it's that nitrite that gives that nice red color. So the interpretation after zinc and HCl, if a red color is produced, that means the organism did not have nitrate reductase, and that the zinc and HCl carried out that reaction. Last one now. What's the interpretation of this organism? You could actually see the zinc powder right here. So we've added the zinc, we've added the HCl, we see it's colorless. What is the interpretation? Well, now remember, if the reagents A and B are going to look for the presence of nitrite, and if nitrite is present, the tube turns red. However, if the tube remains colorless, that means there is no nitrite. So, the addition of zinc and HCl, resulting in a colorless tube, means to me that nitrate was originally reduced to nitrite, and that nitrite was then denitrified to other nitrogen species. Therefore, you could add all the zinc and HCl you like, but that nitrate was already converted. The nitrite was already converted by the organism through denitrification. And so what we have in this tube essentially is that nitrogen gas. Or actually the nitrogen gas probably is escaped from the tube. Alright? So we can see that in the first case, red meant that we had the enzyme when we added reagents A and B. However, a red color here means something different. If you add zinc and HCl and it turns red, that means for us that we did not have nitrate reductase, the bacteria, and that zinc and HCl reduced nitrate to nitrite.